Hello. It's another day, another programming contest. Today we're doing the Codeforces round 904. So let us get started. And it's about to start. I should probably put things up. Okay. And yep, we're getting started. And the first problem is simple design. Given a positive integer. Let's see, and it's good if the sum of digits divisible by 5, okay? And we want to find the smallest integer, which is, okay. Sum of digits, can we just like brute force? Oh, divisible by k, okay, sure. But yeah, we can just brute force it, right? That's kind of dumb, but alright, sure. And then, alright, so we're just gonna read in. I'm having x be n, because I prefer that. And then I'm gonna say I is equal to n, not meow I comma k, or alright, so then yeah, I'm just gonna have this function meow that basically tests if it's good. Then while it's not meow, we just keep increasing it by 1, and then at the end that means z will be good, and we're gonna output it. And then how do we code meow? Meow. Or let's see, let's have meow be the sum of digits actually, and just say meow percent k. Yeah, so that'll just say the meow is going to be the sum of digits of x. So then let's see, let's just do while for x and then we're just going to add, and then of course return red. And this should be an integer. Alright, so like I said, meow's getting the sum of digits, and let's see if it works. Alright, it looks like it's good, and like I said, this is just brute force iterating the input until it works. Yeah, not much thinking involved in that. Alright, let's go to the next problem, which is B, haunted house. So then we're given a binary representation, which is 10 bits, and we want to, what do we want to do? Let me make sure this is looking good. Yeah. Sorry. Anyway, we want to do something. Wait, I should probably, sorry. What do we want to do? We want to swap any two adjacent binary represent, okay? Swap any two adjacent bits, find the smallest number of operations to make your number divisible by 2 to the I. Okay, well let's say, what does that mean? Right, all that means is that being divisible by 2 to the I just means, so here's like your place of values, and this is like the 0 digit, 2 to the 0, 2 to the 0, 2 to the 1, 2 to the 2, etc. And you just say you want all of some digits in the suffix to be 0, right? Easy enough. And all that means is just that in one move, basically, you can then, what do you want to do? You can only swap adjacent ones, right? So the question is, how many moves does it take to swap all the ones out of this area? Well, it's the same as let's see, we need to know basically, we know that if there are ones we have to move, and at some point there might be more over here and extra zeros. But then if we want this to be all zeros in the suffix, we'll need to turn it into something like this. So then we can say, what is the first time we have enough zeros to put in the suffix? And then we know that the first one over here will go to the farthest position. The second one over here, go to the farthest position, etc. So what we're going to do is just iterate through how many, until when we find each of the I zeros, then we can get the answer by saying, apparently it's a previous problem, we're just basically saying the sum of where the position ones will be versus where they are right now. Hopefully that makes somewhat sense. But anyway, let's code it. Where is my... okay. And let's make sure we got the previous one right. We did. What just happened? I said to do that. Whatever. Anyway. So let's see, how will that be in code? Well, first off, the number is in binary. I'm gonna just read this in. There can be at most how many bits? 10 to the 5. So let's just read those in. And then now, I want to reverse it. And the reason of that is I want like a of 0 to be like the 0 place value. And then we're going to say, then let's have a function f be our answers. And we want two things. We want to store, we also need to store how many zeros there are currently. And we want to say if 0 equals 0. Sure. Now we're going to iterate through the string. And we also need to keep track of the sum of one value positions. Right? And then what do we want to say? Or basically, x is going to be equal to our answer, whatever. CO 0. Okay, let's just for clarity, let's just make f equal to L negative 1. No. We'll do it like this. No. No, that's not how I want to do. See, let's like initialize f to 0. We apparently need up to here, or to negative 1. And we need n plus 1 times size of 8. And we're going to see out f of 1. Okay, that's outputting our answer, and now what do we want? Now let's say if I else. Alright, so if it is 0, what do we want to do? We want to say x minus equals x minus equals z. How many zeros we have? Alright, so the number of zeros is plus x minus equals z plus 1 and f of z is equal to x, something like this. Okay, like basically what I'm doing is this. So as we're iterating through the string, what we're doing is we're adding plus 0, plus 1, plus 2, plus, so we're going to have this whole sum. And then for every 0 position, we're going to be subtracting that value. Minus 3, minus 4. And for every 1, we're going to be subtracting what? We're going to be subtracting two things. We need to subtract this value, and we need to subtract what do we need to subtract? No, we don't subtract that. We subtract 0, and here we subtract the 1. That's like getting rid of these. And then for all the 1s, we subtract their own value. So minus 0, minus 1, minus 2, minus 3. And now you can see, right, these are like getting rid of these values, and then the rest of them are like computing the distances between where they are, where the 1 is, and where we want it to be, which is equivalent to how many swaps we need to move that one to where it should go. Okay, sure. Alright then, let's, I guess, what do we want to do? How are we going to do that? Well, I guess we need the count, no, every 1, remember we subtract, not that, subtract where it is in the string, so there should be minus 4. So we're going to always say x plus equals I, so then if it's a 0, we're going to subtract, like, what number 0 it is. Otherwise, we're going to subtract its current position. Okay, and that seems good. And then, wow, that took way too long. I'm sorry we took so long on that. But hopefully now it makes sense. And hopefully it works. -1, 2/4. Okay, it looks like I did it correct. So let's submit it and hope for the best. And actually, wait, let's make sure. Can this be a long value? Yes, I think. Okay, let's make this long one. Right, I think the answer can be like n plus n plus 1, which is like n squared, and that can be big. So we want to make sure we don't overflow. Did we copy the right one? Yes, okay, good. Let's just see if it works. Oh my, why? Okay, so why did it not work? Did we get the bounds right? Okay, it doesn't look like a problem with the bounds. Oh, well, we even said that. We didn't fix the making x a long, which is also storing that. We're so stupid. Okay. This right now. Nah, such a stupid thing to get penalty on. Alright, now let's go to the next problem. medium design. What is this dumb problem gonna be? I bet it's gonna be a medium problem. Okay, so we got an array that's all zeros, and we got some segments, exciting stuff. And what are we gonna do? And we're gonna subset. Alright, we're going to, for each index in each segment in order, you increase AI, and you increase that value. Okay. Oh, okay. So basically, you select a subset of the segments. You add 1 to every value on the range corresponding to that segment. And then you compute the max value among all values of A, and the minimum value among all values of A. And then you subtract the max minus min. And that's corresponding to the cost. You want to have the maximum difference between the maximum and minimum. Sure. Alright, so then what does that mean? Let's just label this B. Now for C, we didn't have to think about A, so whatever. For C, what do? So let's kind of draw an imaginary array. And we want to maximize max minus min. So ideally, we want a lot of segments covering some specific element, and then not covering some other element. So I think the natural thing to think about is, what if we fix one of the maximum or minimum? So I guess let's imagine fixing, oh yeah, so here's a easy observation, right? Let's say an interval covers both the maximum and the minimum. Then it's completely useless, right? Because you'll add 1 to the max and 1 to the min, so we don't care about it. Also, so no interval cover max and min needed. Similarly, we do not need to ever, what was I going to say? Oh yeah, also, any, we can just fix max min indices. Because never over answer, right? So you can imagine kind of an n cubed or n squared, whatever, n squared idea is that we can just fix what the max and min are, try all combinations, and then try to put as many intervals on the maximum as possible. Then now let's just imagine, right, we just fix one of them, a maximum, and see how many intervals we can pick on the maximum and not on the minimum. Well, also, I think it's pretty clear that since we want the minimum to not be with the maximum, the minimum is either going to be min 1 edge can be index 1 or m. Alright, hopefully that's clear. Basically, since because of this, we only want intervals, as many intervals as possible to cover the maximum, and then we might as well only pick those, and then the minimum can be one of the other, the opposite of the array. So then, in other words, we can kind of run the same algorithm twice. Let's fix the minimum to be 1, and then run through fixing maximum and see what's the best we can get, and then the same thing. yeah, it'll make sense in code. So let's just code that. It's really easy. And I spent way too long explaining, and that's going to hurt my time penalty. And alright, so yeah, so I'll have the intervals like this, hold their left and right point, and then what do we want to do? And have a vector of pairs. Something like this. Actually, doesn't even matter. We're just going to say every left bound is like a +1, and every right bound is a -1. Sure. Okay, so let's just iterate through the segments that we have. And then we're going to say if I.s equal to 1, then I plus I s equal to -1. Alright, so what we are saying is that the interval from whatever, so then alright, so what we're saying is we're having the pairs with the left bound paired with 1 and the right bound with -1. We're going to sort them by their value, then we're going to loop through them. Basically, every time we hit a 1, a new interval is starting. Every time we hit a -1, new interval is ending. And we can keep track of how many intervals we have. And we're just going to run twice. Wait, no, we need to keep track of the index. Shoot. Okay. Alright, let's do it like do it like this. Okay. What are we even doing? Alright, so what I'm going to do is, alright, it's easiest to just coordinate compress stuff. So that is what I'll do. I don't know why I'm like not thinking, but whatever. No, I want to do sort b alright, sure. And we're just gonna kind of implement it like this. I might dislike that soon, but whatever. And we're gonna go through might be missing. Okay. We're going to make this array D, which is just for coordinate compression. And we're going to have a vector, which is the indices at each point. No. Oh, why am I saying that? What are you doing? Okay. Having this be V again. Yeah, maybe you should think before you code, but whatever. Now we're gonna do is, alright, so we're compressing A of I to be the lower bound of B plus K. And then we're gonna say, we're gonna put that first we need to like clear out the vector as well. Okay. Now we're just going to go through the vector, right? And we're just going to go through it twice. Okay, sure, yeah. Actually, I'll do AOI minimize. It doesn't even matter. We're going to zero index it. So now the interval is like inclusive on the left, exclusive on the right. And then we need to say both cases, or iterate over the cases of the minimum. So it's like, what, 0? So what is the one it can't include? 0 and M, sure. Yeah, so this is the minimum location for J. Now we're going to keep track of, no, that should be I. And we're going to keep track of basically the best value overall. So T is like what we're excluding. I is our current like compressed value we're at, and X is how many intervals you're covering. And then we say if A of J percent N is greater than T, or A of J percent N plus J percent N is less than or equal to T. Then we do X plus equals J of N. J is less than N, pressure 1 colon negative 1. Sure. And now we do red is equal to max of reg X. And then we min at index 0 or M is 1. Max and min never share interval. Sure. Wow, that was a real sad implementation, but we finally got through it. Vector. Oh, alright. Also, we need a reset k. And we need to include vector. And that should all be good. One, 3, 2, 3, 4, 4. That looks good. Hopefully I didn't make any dumb mistake. I don't think I did though. And let's submit that. Oh, I can't believe we took that long for that easy of a problem. But it's whatever. We getting through it. We getting through it. Oh man, let's take a break. What? Wrong answer on pretest 3? What are you talking about? I Let's see. So we are setting. What's the maximum bound? NM. Oh, right. Okay. So first off, I said here it should be less than M, right? M minus 1. And B of. Alright, let's get the actual value. And then test it with the actual value, right? I think that's the problem. Right, because we were chord compressing, we weren't comparing with the indices correctly. Okay, good. And what's our standing? Why does it not? What? Okay, well, I'm doing, Actually, I'm doing pretty good, but still seems kind of sad. My penalty is very bad. 2 wrong submissions already. But going to D, we have an array of integers from 1 to n, and they're good if there's no integer such that a of I is divisible by a of k, and aj is divisible by ak at the same time. Okay, doesn't that just mean that their GCD is 1? Am I clowning? What? What? A pair of integers, ij is good. Oh. They can't be divisible by the same value in A. Okay. Sure. Alright, so I'm pretty sure I know how to do this. So first off, imagine we want to count, like, instead of counting the good pairs, we're going to count, like, the bad pairs, I guess. Let dp of I equal number bad pairs with greatest common with GCD in A as I. then, right, so dp of I is like number of bad pairs with the greatest value in A dividing both A and I and A of J being I. Now we say like dp of I equal to number pairs divisible by I minus dp of x times I right? So then we can just say every single pair divisible by I, where both are divisible by I, are like bad pairs, but we'd be overcounting the ones that we already had that had a greater common divisor. So we just subtract those out. And then it's obviously just like the harmonic sum thing. Since this is to subtract this out, it's only iterating over multiples of I, then we use like the harmonic sum analysis thing and see that it's n log n. It'll be pretty clear in code. Guarantee the sum. Okay, good. Yeah, whatever. Wait, what? No. Oh, but it's... But there are multiple test cases. That's a little bit weird. Right. Alright, so like, this would be the solution, except there are multiple test cases. Right, because what I need is to iterate over the values of from 1 to 10 to the 6. Is there a way I can do it without doing that somehow? The sum of n over all test cases not exceed 10 to the 6. Oh, a of I is less than or equal to n. I'm so dumb. Okay, sure, yeah. So then max n equals n. I was like, what? No. Okay, so Cn, but yeah, that's not. Alright, so yeah. The max bound on a of I is n, which is why this works. And then let's do mem set a sure. Now we want to or whatever. No, whatever. A of x. Alright, so we're just counting. A is going to be holding for each value. How many values were we inputted? That how many values that we inputted have that value. Right, so it's not actually the A in the problem, but whatever. And then now we'll just do the DP like I said. And then we need to iterate over. Okay, so dB of I. Let's do this. Return x times x minus 1. Alright, so there's the pairs of like the same value, right? plus equals 0. Alright, now we're iterating over the multiples of I, right? Oh yeah, we only do this if a of I, and then only if a of j, and we need the x. So dp of I plus equals x. Or does it even matter for this? Whatever, let's just keep it like this. X times a of j plus minus if j is greater than I, and then we do x plus equals a of j. Yeah, sure. That looks good. And now we basically want, and then we just subtract out these pairs. And then we just outprogram. Okay. I don't know. These type of problems are pretty obvious, where you know that like multiples matter, and the bound of values is pretty small. So then you just like iterate over all multiples and do a DP like that. Except for why are we getting the last thing wrong? It's rather concerning. Wait, what are we doing? It's getting all correct except the last one, right? There wasn't any like update or something. Alright, let's think about it. So this is multiples between different values. This is the number of pairs of the same value. And then we're subtracting out those, yeah. X plus equals a of j. Alright, what could I be missing? Why is only that one wrong? That doesn't even make sense. 82. What is 21, 210? So it's like a lot of pairs. Or what are the pairs that are not bad? Do we even care about if a of j here? I don't see what's wrong. Am I missing something? I mean, I'm just gonna submit it and see if it works. This do not be making sense to me. It's not working. What? 42 versus 82. Why? Okay. Alright, are we overcounting somehow? X times A of J. How would we overcount? I don't know. How could we overcount? Okay, so you have 18 in the set, being the GCD. You have like 12 in the set, being the GCD. And then you have 6, and you subtract from 6 twice. What? Let's see. Let's just see how. Okay, so we have. Well, first off, why aren't we iterating over 19? That seems like a problem. Oh, never mind. There it is. 19. 10. Sure. It's all pairs of 19. 2. 3. Actually, let's do it. Yeah. Okay. So we have 5 values of 19, and that's 10 pairs. 5 values of 18, and that's 10 pairs. 1 value of 16, no pairs. 8 values of 12. That's 28 pairs, sure. Wait, 8 times 9 is 72. What? 8 times 9. No, 8 times 7, 56, 20, yeah, sure. 3. We have 1 value of 3, okay? And that adds, let's see, what should 3 be? Just doing it by hand. Well, we should be adding the pairs that 3 is paired with. So we have 8 plus 5 plus 5. 8 plus 5, no, just 8 plus 5. 8 plus 5. And then we have the pairs between 12 and 18, which is 53. Are any of those wrong? I don't see how that's wrong. Right? Alright, what about with 2? 2 we have. What is everything that can pair with 2? Well, we should have 8. What? Bro. Alright, come on. What are you doing? 2 should pair with the 12. Should pair with the 12 and the 16 and the 18. What should the 12 pair with? 12 by itself is going to add 28 pairs, right? But we already counted those. What are the new pairs? 12 and 18. What's their? Yeah, so like plus 5 times 8. No, we said that already goes with 3, so we don't add those either. Okay, there's a problem, right? 12 and 18. We're adding the pairs of 12 and 18, but we're not subtracting. What the? What is it doing? Yeah, so we're not subtracting out the pairs with 12 and 18. How do we know that we need to subtract those pairs, right? The ones we're overcounting are values that we haven't gone over their GCD. Alright. Instead of GCD and set equal I guess we just make their GCD equal I. So how would that work? Alright, how many pairs are there? Divisible by 3, indivisible by 2. Let's subtract out pairs with GCD greater than 3 and 2. Okay, wait. Alright, so now I'm thinking, instead of having it with like GCD in A as I, we just say their GCD is I, right? So now we want to take, so first off, let's set like f of I equal number pairs divisible by I. Okay? Then dp I equals sum of f of x times I minus, now we need to subtract the overcount, right? So what are the ways they can overcount? Well, the other thing we need is we need to subtract out minus dp of x times I, but then the ones we're not counting for are the ones that have their GCD equal to this, right? Minus sum of f of j time number of pairs. Okay. Number of pairs divisible by I, sure. So for the case with, what do we have? The problem case is 12 and 18, right? And we have 2 and 3 in the set. So we want to say we have the pair 12 and 18. And then that gives a pair to 3 and 2. And then somehow we want to make sure we're not overcounting that. Okay, so what do we do? Well, oh. Now 1 is not in the set, but these ones are. So you want 2 plus 3 of 2 plus f of 3 minus f of 1. Is that true? Do we just... They're gonna be like... I don't know if that's right either. How do we know how many times it'll be overcounted, right? Right, we can have something like 2, 3, 5, and then we have like 30 and or yeah, 30 and 60, right? So this pair will be counted for 2, 3, and 5, which are all relatively prime. How do we know to subtract out twice? Okay. This problem is more interesting than it first appeared, maybe? So we have... How do we know to group this only once? 2, 3, and 5. Actually, their GCD is 30, so that's a bad example. Wait, how did that... Wait, what is the GCD? Oh, wait. Bro, you're so dumb. Alright, so first off, we want to be looking at the GCD. Why are you looking at this? The 3, you have 2, 3, and you have 6, right? So, okay, so we want not just the elements in A, but also if any of their multiples is in A. Bro, you're so dumb. Okay. So all we have to do is add an extra array. And then we just first go through it. Alright, we're gonna say B. Okay, there. So now we're marking all values that are multiples. And now we just do this. That basically fixed it, right? Okay, that was pretty dumb. Right, so you allow, basically, summarizing what I did. You're allowed to count, or what? What happened now? 0, 3, 20, oh, now we have something, another. Well, okay, regardless. Basically, I'm allowing the DP values to also count multiples of A. So, what is like the GCD? Multiples of A, whatever. What is the problem now? So here we have 23 for just case 3, which is obviously not right. So 9, we have 3 values and 3 pairs. 7, we have 2 values and 1 pair, sure. 6, we have 1 value and 0 pairs. Yeah. 4, 2 values and 1 pair. Okay, and 2. Alright, so here's where the problem, I guess, lies. And what is the problem? So the 2 will be paired with the 4 and 6. So that's 3 pairs. Oh wait, so we have the 3. Wait, why is the 3 being counted? Oh, what the... That was dumb. At least it's not any penalty. Okay, good. Looks acceptable. Yeah. Oh my god, my place is so bad. Okay. E, hard design, right? Is it really going to be hard to design it? We'll find out. So, you have an array, and you want to make all the elements equal. Very exciting setup. And you want to perform some operations. You want to pick pair of indices and increase BI by 1. Wait, let me just real quick say is by I is multiple of A. Or what? Oops, not that thing. Or whatever. With GCD. Multiple. Yeah. Okay, whatever. Oh, okay. Looks like it's gonna be some. Alright, most likely it's a square root problem or a convex hull trick because there's a square operation. I don't know, I'm just randomly guessing. But anyway, what is the problem? You pick a pair of indices and increase all the values in a range by 1. And then the length of the range. A squared is the coins, sure. Define with a pair. Count. And the cost. largest total number of coins you can receive. Alright, so you want to, like it says, you want to minimize the number of operations, and then among those, maximize the total number of coins you receive. Please find the value of f for all cyclic shifts of a. What are the bounds? And it's 10 to the 6th. And values are up to 10 to the 9th. And okay, sure. This looks like a very ugly problem. Well, let's see how it goes. Whatever. Alright. Well, I guess first off is just finding the strategy for count. Or basically a single cyclic shift set. Alright, what will that be? Well, I guess let's think about the differences, right? So we have, let's look at the example. 3, 2, 4, 5, 1. When we pick the pairs to increase BIY1, what does that do? Actually, let's replace the array with the difference array. So we're going to turn it into, we're going to only look at these. So it's like -1, 2, 1, and -4. Now, when we pick the value LR, it's like picking a pair. Alright, this transforms the operation into what does it turn it into? +1. We're adding 1 and subtracting 1 to a pair. Right. And then it's what is the smallest number of operations to do that? Right? Sure. And we can like subtract 1 off the board because we don't care about that difference. So I guess we know that for all the negatives we need to add 1, but then that allows us to get a free subtraction after it. So then this is like, back to our example. Let's move things around. Alright, back to our example, right? We have, it's going to add 1 to our operation. It's going to add 1. It's going to add 1. It's going to add 4. And negative val gives free positive after otherwise some values, which is equal to 1, 2, 3, 7, right? For the second case, where's the third case? Alright, 1, 2, 3. Yeah, so we get 7, right? Values is count. Okay. I think that's pretty clear. And then how do we affect cost? Maximize cost giving free positive later, farthest away possible. Right, we can do this greedily because you're maximizing the sum of squares, and like it's always better to pick intervals like this than intervals like this. Right? Yes. Okay. So now, alright, so that's easy. Now the question is cyclic shifts. How do we deal with this? Well, how does the difference array change? So 3, 2, 4, 5, 1 goes to 2, 4, 5, 5, 3, 1. Right? And let's look at the difference array. This is -1. Huh? -1 to 1. -4 goes to 2, 1. What? -4, 3. Sure, we just take the, so you just like delete the first value and then add the new one to the end. Okay, that is easy enough. Now the question is, what does each thing get paired with? Okay, so the main question is, how do we pair the negatives with positives, right? Oh yeah, let's look at their, oh yeah, let me just like draw the intervals, right? So this +1 corresponds to this interval. This right here corresponds to this interval. Oh wait, no, we get a free subtraction here, right? So the +1 gives a free subtraction right here. No, we want to actually make it go to here, right? We'll just subtract 1 here. We'll do 2 subtractions here. And some more subtractions here. Right, this is what it should look like. And of course, we get 3 squared times 3. 9 times 3 is 20. What? No, we get 2 squared times 3. 4 times 3 is 12. 12 plus 9. No. Wait, this is dumb. What are we doing there? No, this should be here. This is 0, huh? What are we supposed to get? 18? What did I do wrong? Alright, obviously I'm doing something wrong, right? -1. I need to add 1 here, right? No, so we do 1. No, what? No, we literally said this is better. It should be like this, I guess. Okay, so that is 3 squared. 9 plus 2 squared, 4, 13. So 1 squared. What? 15. Wait, how are we getting 18? 3, 2, 4, 5, 1. 3, 2, 4, 5, 1. Alright, add 1. Oh, wait. Okay, never mind. I think I was correct before. It was like this, 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 and that. So, this is 3. 1 plus 1 is 2. 2 squared. What? Wait, we agreed. You want to maximize the total number of coins. Right? Right. Maximize the total number of coins. Wait, is this even right? So, just changes it to 3, 3. Oh, right. It should be like this. This. Alright, it should look like this. Okay. So this is like 2, 4, 5. No, one of these should be Okay, so this is like 3. 3 squared is 9. Plus 4 is 13. Plus 1 is 14. Plus 4 is 18. So it looks like this, right? I don't know why that took so long. That was pretty sad. Anyway, yeah, so that's what it should look like. So I guess like the greedy strategy is what? When I go through okay, it's actually good to pair a plus with the closest, or like a minus with the closest plus. Closest, my bad. Right, because then, right, because the other way we could do it instead is doing this and that. But we don't like that, because we could do this, and it'll always be better to pair this closer, so then the farther one goes over it. That sounds right. Okay, yeah, I agree with that. So the question is, what? When we add a positive at the back, what will happen? Okay, so what are the things that happen, I guess, right? When you add a positive at the back, that's not bad, because you just need to find the closest unpaired negative and pair it. Add back, find closest unpaired negative. Add minus at back. Add two unpaired negatives. Right, so these are fine. The problem is, oh yeah, delete plus from front, do nothing. Now the main problem is deleting a subtract from front. We need to get rid all pairs. Okay, that's a bit of a problem. And then, not only do we need to get rid of all pairs, we need to maybe pair with new values. That's not very ideal. How much time do we have? Okay. Well, let's see. There's this. Oh, yeah. That was a little annoying. Okay, what are we doing? So, I guess processing, just like going in order of like shifting one element at a time, a cyclic shift, seems quite hard, right? Because if you have like -1 plus 1 plus 1, right? The problem is, so right now this is paired with this, and this is paired with this. Wait, is that even true? That's not even how it should be. Shoot. Should be like this, right? Farther than future free, but closer than unfree. Okay, so what I mean by this, right, is you'll have something. So let's say you have an array like this. You want to pair this negative with the farthest positive, but not with this one, okay? So you do need to pair it with something. So you pair it farther than this one, but you don't pair it past where it needs to be. That's how you should be pairing things. Okay. So what you do, but that makes it easy, because now you just like get rid of these pairs, because these ones are inside, so it's not like they're gonna change what they pair with. All pairs. How does this change? Find. Wait, so how does that change the one on the back? Find closest unpaired negative. Okay, add to unpaired negatives. Oh, just like. Wait, this is easy, right? Just get rid pairs with positives. Yeah, so they'll always be kind of like this in pairs always parenthesis. So, alright, so you'll never have any pairs that cross each other. And then you can have like something like this, where there's another pair here. Okay. Sure, I agree with that. Okay. The question, though, I guess in general, is what? Alright, how long does it take to find the pairs, though? That's what I don't know. Right, the main thing, if this was plus or minus 1, I think it's all pretty clear at this point. However, when you have the values up to 10 to the 9th, you obviously can't pair like one single value at a time. But is it enough to just pair in like groups, I guess? Like basically greedily find like greedily pair min minus plus subtract repeat. Is that good enough? What would the time complexity of that be? I think it's good, but it seems scary to actually deal with. Well, we can imagine actually, okay, it's the same as the complexity of finding the pairs for the single array with that's like duplicated twice. Find pairs duplicating array twice, right? That sounds good. Sure. And I mean, you can just see by that the complexity is good. Okay, yeah, let's implement it. It'll be more clear when we implement it. One, two, three, four, five, six. n into a max n, and we're gonna duplicate the array twice because it'll make implementation easier. How does it work when we shift? This is supposed to be 3. It's supposed to be 2. Right. But let's just look at what this looks like here, right? That's the same as going 3, 2, 4, 5, 1, 3, 2, 4, 5, 1. Alright, so it's like going -1, 2, 1, -4, 2, 2, -1, 2, 2, 1, -4. Right, and then it's just like taking any group of 4. Okay, sure. All the cyclic shifts are just looking at intervals of 4 and the duplicate array twice, difference array, correct? Agree, agree, agree. Yes, no. I think so. Yeah, okay, that looks good. That will make life easy. So let's do that. And then now let's go. I minus equals a of I minus 1. Okay, now we got like all the difference arrays. And now what we want to do is just find the pairs. So how is that going to work, right? Let's just, I guess, like readily hold a set of unpaired things. What do we need the pairs? Okay, kind of need like them. Alright, I'm just gonna like hold them kind of like this as a word. Right, I'm just gonna hold them kind of like a graph, maybe. I'll also hold their direction, I guess. Okay, so it's gonna look like this. We're gonna need like a stack, I guess. And stack int yeah. Alright, well, not this empty. Pop. Alright, let's see. Let's get the pairs we need. So, if I is less than 0, right? We need to add to the stack. Messed up. Push I, a of I. Sure, right. Else we need to get stuff from the stack. Wait, no, we don't need 2 directions, right? Because the negative's always going forward. Yeah, whatever. Wow. It's not empty. And 4. And I. And I. Alright, int x equal min of s dot top dot s min of I dot s I is x s s G of, this should not be, this should be J. Really, it should be like, let's make this like X, and it's like Y, and then X minus equals Y, and this minus equals Y. G of I, push back. F. Y. No, I want this to be J. Because, yes. J, X, X, J. Let's just at this point, let's just do this. G of I, not push back. J, G of S dot top, and F, not push back. I, comma J, right? So we're just getting the pairs from both ends. Sure. And then if J equals S dot top, S dot top. No, this should be X. What are you doing? X. 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 Yeah. Okay. I hope you're able to update a value on the stack, but I think you can, hopefully. But you know, let's just hope for the best and not worry about it. Okay, so this gets like all the pairs, right? And it's pretty easy to see when you implement it like this, that there's only ON different pairs. Now, we're gonna do like a two-pointer type thing, right? Okay, so now let's do like this like two-pointer type thing. Okay. I guess one question though is, let's say we have a bunch of values x, right? How do we all and we want to have the sum of x squared. How do we turn that into the sum of x plus 1 squared? Well, it's like, it goes to sum squared and goes to sum x squared plus sum 2x. Sure. And then sum x goes to x plus 1. Oh yeah. Number x. Sure. Okay. Yeah. That's easy enough. Okay. So x is going to be the count and the cost. So first we need to add the new values to our thing, right? if a of I is less than 0, else. Okay. Whatever. What do we say? Add plus to back. Wait. Do we even need to do this stack twice thing? I don't think we do, right? Do we need to? We're doing like the same thing, so why would we do it twice? Right? Yeah. Okay, yeah, we do not need that twice. Well, we still do kind of need this though. But we just add this here. Now. If I n, if a of n minus I minus n less than 0, you only need to go to do one. Okay, now if a of I minus n is less than 0, so we need to undo them. Okay, we just need to like get rid of these pairs, right? For Pij and G of I. We need to hold the count. Oh, we do need 0. No, we do need a 1. Okay, let's see. A of I minus n is less than 0, right? J is equal to what? What do we want J equal to? Okay, wait, first, let's like add these things right correctly. So, remember, how does it work, right? A negative value needs to extend forward. So, let's see. sure we okay, so actually, no, we don't need Z extra. We need Z. So this is like the count and cost. And we also need like the we also need no. Do that. And then we also need okay, that should be good. So when we add this, this is adding 2. Alright, first we need to shift everything. Shift Z. Okay. Remember, how does this change, right? We need to add. What do we need to add? So the negatives reach to the end, right? So when we shift it, we need to add 1 to everything. So Z of 0, 2, plus Z of 0, 0. Okay. And minus equals okay, should be like this, right? We're just shifting the squares. How much time do we have? We're tight on time, but we still have the chance to make it. So this 0 is easy. Z of 0, 0 plus plus. No, actually, let's do all this first. Z of 0, 0 plus plus. Z of 0, 1. Plus plus. Come on, Z of 0 plus plus. 1, 0. N, right? N? Is it N? It is, right? Are you sure it's N? No. Oh my god, is it n or is it not n? When you add, what happens when you add something to the end? A pot. When you add a positive to the end, what happens? Positives go forward n minus 1, not n, right? And why would you ever add n? Right. Okay, it looks like this. I think we're gonna have to add in mods for all of that stuff. But like, I don't want to. What is happening here? Okay, this should all be mod, right? One, two, three. Ugh. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we have like the whole idea, but we're implementing so slow. Oh my gosh. Sure. Right. Sure. We don't really have to do plus plus for this one. Whatever. We're gonna run out of time. Okay, so that's good. That's good. If this is positive, what do you do? I mean, whether it's positive or negative, by the time it's there, all you do is change the count, right? Because it's already 0. Wait a second. I just realized I've only been adding. Oh no. Oh no. Plus equals maybe by. You have to add 1 for every single thing, right? Alright, it should be like this. Okay. You agree? Everyone agree? Okay. Now, you should just do 0, 0. You have to subtract anything. I minus n. Wait, so the plus ones, right? What do they become? They're like n squared at the end, right? N squared. Oh, we don't have time. Shoot. Whatever. I'll just like try to finish regardless. Okay. What do their distances become when we subtract them? They're like n, right? They are n. Sure. Oh, I do. Because it's negative. There should be percent mod. This one's also percent mod. And this should be I minus n. I minus n. Minus n. Also, oh yeah, so you're like kinda not even dealing with pairs correctly yet, or whatever. We'll deal with that later. Now for these, right, it should be minus a minus n. Minus n, not, this is now, not n, but negative 1, right? And then this is like negative 1 squared. Okay, because all the negatives have turned in, all these ones have turned into all of these have turned into negative 1. All of these have turned to n. All of these have turned into negative 1. Right? Okay. Everyone happy with that? And the content doesn't work. Okay. 1/50th place. Not ideal, but it's whatever. Let's finish implementing this problem. I'm pretty confident in my idea, but it's kind of cancer to work out the details. Oh no, it's a okay problem. it's just not very interesting. The setup. It's like pretty contrived, and the ideas are pretty standard. It's like working out details. D was slightly interesting, but it's also pretty standard details and just working out standard ideas and working out details. C, okay, I feel like all the ideas in this were pretty standard. Like I've seen same sort of things. Nothing really blew my mind. I did like the implementation was a little bit tougher than some other CF contests. I think that maybe made it more interesting. I enjoy having to think about how to implement, I guess. But yeah, so, I mean, let's just finish this the rest of the time. Hopefully, system testing will be done. Okay, let's see. How will we finish this? Okay, what do we have left? We don't need to push this, right? What? No. What we need to do is, for when it's less than 0, we need to get rid of the pairs. Oh yeah. We need to add, like, these pairs to the answer. Okay, so how do we add the pairs, right? What we need to do is we say okay. So first off, we need a like okay, we need like a better way to do this. Add actually never mind. I don't want to finish this. Whatever. I'll just save what I have. I don't know. Hopefully we get that general idea of how this works. But yeah, I don't really want to finish this, so I'll just stop here. And yeah, I guess then that's all. And goodbye.